Hey everybody, this is Longo, and in this video we are going to cover complex numbers in both the polar and rectangular planes. And just a reminder, complex numbers are a combination of real and imaginary numbers in the form of a plus bi, where your a is your real number and b is your imaginary number. Now, on the coordinate plane, your real number and imaginary number are pretty much just your x and y. So graphing them is actually very easy to do. But we also need to find the absolute value, which is also known as the radius. And to do that, we're just going to use the Pythagorean Theorem, also known as x squared plus y squared is equal to r squared. Here's how. X is 4 and y is 3. So if we just went out to 4, 3, we're just going to plot that dot. Now, if you think of it in terms of x and y, that's your Pythagorean theorem. It's just a right triangle. But since we're on a polar coordinate, also circular, this is going to be our radius. So all we have to do is r squared is equal to 4 squared plus 3 squared. That's going to give us r squared is equal to 25, so r is equal to 5. So this r is equal to 5 is also the absolute value of a complex number. Okay? Now, if you ever just have a real number or an imaginary number, the work is still the same. So for I, this would be our y value. This is also the same as 0 plus 4i. So if we were graphing this, we would just go up 4. And as you can see, that's where it is on the polar coordinate. To find the absolute value or the radius, we would just do r squared is equal to 0 squared plus 4 squared, which is 16. So the square root of 16 is 4. So r is equal to 4. Again, that's also the absolute value. Moving along. Converting. A couple of things that you need to know and a few things that you need to remember. So rectangular, we already talked about, is a plus bi. Now polar, you need to remember that x is equal to r cosine theta and y is equal to r sine theta. Now there's two different forms for when you are working with these. Now this one will work for both. So if you have polar, we have r times cosine theta plus I sine theta. So remember, if we distributed this, we would have r cosine theta, which is our x, and we would have r sine theta, which is y, with the I on it. But this is the rectangular form that we use. Now, if you are in polar, you can use a shortcut, and it's r cis theta. That just means cosine and I sine theta. But you only want to use it for polar as a shortcut, and you'll see why in a little bit. Okay, so let's start. The first set of examples we will do is converting rectangular to polar. And you have to be careful of if you're in radians or degrees. So I'm going to just do everything in degrees, and when necessary, just convert it into a radian. So it'll be much easier if you have your graphing calculator set to degrees in case you need to work with it. Okay, so this first example, we have 3 and negative I root 3. So before we do anything with that, you want to think about which quadrant you're in. So this is going to be positive x and negative, so we're going to be down here. Okay, so first thing we need to do is find our radius. So that would be r squared is equal to 3 squared plus the square root of 3 squared. So r squared is equal to 9 plus 3 is 12. So r is equal to 2 root 3. And now we have to go find our theta. Now theta is something that we covered the other day as well. So for theta, remember, it's just the inverse tangent of y over x. So the other day we talked about when you're looking for theta, it would be the inverse tangent of y over x. So that would be a negative root 3 over 3. And once you type that in your graphing calculator, you're going to get theta is equal to a negative 30 degrees. But we are looking in radians now. So you just have to remember 30 degrees is pi over 6. So this is negative pi over 6. Again, it's just unit circle stuff. Now, you have to remember we are down here in quadrant 4. So negative 30 degrees in quadrant 4 means our final answer is 330, but since we're in radians, it is 11 pi over 6. So to write our final answer, all we're going to do is, since we're going into polar, we can use the shortcut. But just to show you what it would look like, it would be 2 root 3, and then parentheses, cosine of 11 pi over 6 plus I sine 11 pi over 6. But since we're in polar, we can just write that as 2 root 3 cis 11 pi over 6. Okay? Now the next one, we're going to just keep it in degrees, but I would like you to pause the video and try this one on your own and click play when you're ready to see how it's done. Okay, so for this one, the first thing you should have done was find your r squared. So r squared is equal to a negative 3 squared, but remember whenever we square anything it becomes positive, plus 2 squared. So that's going to give us the square root of 13 for r. So we've got that part. Now theta, again, just like the other day, we're going to do inverse tangent of y over x. So that would be negative 2 over negative 3, which is going to be the same as 2 over 3. And theta this time is going to give us 33.69 degrees. And it's okay because we're staying in degrees, that is a weird funky decimal. So to put this together, you have to first remember quadrant is important. So negative negative is going to put us in quadrant 3. Okay, so you have to be careful of that. So that means 33.69 is in quadrant 1. We need to go 33.69 degrees past 180. So the real theta for this particular example is going to be 213.69 degrees. And since we're in polar, we're just going to skip straight to the shortcut. And we're going to say that our final answer is the square root of 13 CIS 213.69 degrees. Okay? And that's that. That's how you go from rectangular to polar. Now, the last two examples are going from polar to rectangular. And this is not that bad at all. It just comes from the unit circle. Like many things that we've been doing lately, it comes from the unit circle. So, to do this, all you really have to do is, I would write this in this form. This is 8 times, now the cosine of 7 pi over 6, this comes from the unit circle. So the cosine of 7 pi over 6 is a negative root 3 over 2. And that's plus I. Now the sine of 7 pi over 6 at that is negative 1/2. Okay? So that's really minus I times 1/2. So then, from here, you're just going to distribute your 8. So 8 times a negative root 3 divided by 2 is a negative 4 root 3. And 8 times a negative 1/2 is a negative 4i. And you're done. That's it. You are done with that question. So going from polar to rectangular is a very easy thing to do. Next example. Since 4 is nowhere on the unit circle, this is just a calculator problem. So what you're doing is just distributing your 5. So 5 times the cosine of 4 plus I times 5 sine of 4. Type that in your calculator. 5 times the cosine of 4 is a negative 3.27. And then 5 times the sine of 4 is a negative 3.78 I. And that's it. You're done. Okay? That's it for this video. This is Longo and I'm out. See you, bye.